All right, if you're watching this video, it means I'm not there. But I told you I wasn't going to be there, so it's okay. I have to take that math test, and nobody's looking forward to that, so wish me luck in your head. Don't, actually wish me luck, because they take your cell phone. All right, so we're going to go over the 6-4 homework, and we're going to go over it. If you haven't started this yet, I suggest you give it a shot maybe before this. But if not, we're going to go over it just like we would on a Wednesday. So I'm going to hopefully take about 25 minutes to go over this. It's not going to be a short video. So the first question says, the table shows the values for the expression of 10x squared and 2 to the power of x. So we're describing how the values of each expression change as x increases. Predict which one's going to have the greater value, and then we're going to find which one's going to have the greater value. All right? Make an observation about how these values of these two expressions change as x becomes greater and greater. So I screenshotted this, and I actually put it over here on my whiteboard so that it's a little bit easier to work with. So let's see what kind of observations. Pause the video, right? Pause the video here if you need to, and talk about it. Think about what kind of observations. So let's make an observation. What do we observe with the current values? So I don't know about you, but certainly I personally observe that the quadratic is much larger. Also, I observed that I can't spell quadratic, so, whatever. Right? We're seeing that it's much larger right now. Much larger when x equals 4. So what do I mean by that? Let's click somewhere else. Let's draw what I mean. So when x is 4, we're looking at this section right here. And it's pretty obvious that this is 10 times, literally, 10 times as much as this one. Just a quick reminder, this is the quadratic function, right? I'm going to try to draw a Q here. And I'm going to pause. You're going to tell me what it is. I'm sure, just like Dora the Explorer. That's right. It's the exponential function. Maybe you didn't grow up watching Dora, but there you go. All right, so that's our exponential function, right? It's when the base is here, we'll write it down in case you can't hear me. The quadratic is when the base is a variable and the exponent is 2. And the exponential, aren't you excited that this is not the test that I'm taking right now? That's not a spelling test. I was not good at spelling. The exponential is where a number, any real number, and usually positive, is the base and the variable is the exponent. Pause for the little squiggly line. All right. So in case you forgot what that is, I'll just highlight that for you so you can remember those definitions. All right. So we're observing this. So what do we think is going to happen? Well, maybe you remember, maybe you recall that usually the exponential function gets larger eventually. We had several, still not a spelling test. We had several rounds of asking this question in different ways. I made it a warm-up at one point. When x is very large, the exponential problems or equations or patterns will be bigger. Right? We saw that, if you recall, in your notebook. If you recall back in your notebook, we saw that when the quadratic function got to 1500 when x was 50, enough to buy a really nice pair of shoes. Whereas the exponential function, did I just say that wrong? So the quadratic function got to 1,500 or 15,000, whereas the exponential function got to like the number of grains of sand on Earth. So money to buy a pair of shoes, number of grains of sand on Earth. When x gets bigger, right, for large values of x, the exponential function almost always gets bigger. The question becomes, when do they cross paths? Right? And we don't know when they're going to cross over. So we're going to have to find that out. So let's go ahead. Let's predict which one. So we're going to predict that eventually, the exponential will be larger. But we don't know when. Right? Hopefully you can read that. So we're going to go ahead and find the values of this. So let's plug it in. So on our first one, let's build a table. I like tables. Tables are nice. We were building these tables yesterday or Monday, depending on which period you are. And this is a pretty standard table that I build in my class. So we have our inputs, and our inputs are x values. We have our equations, which is 10x squared. Remember that this little caret x is the symbol that we use when we can't use superscripts. And then this is our y value. So we're doing 8. And so that's when we're going to have 10 times 8 squared. 10 times 8 squared. That is 10 times 64. And if you're good at math and you can do that in your head, that's 640. Wow, that's still pretty big. 640. All right, let's do 10. So at 10, we're going to have 10 times, I'll pause, I'll ask you. That's right, Dora. It's going to be 10 squared, right? And if we put that in, 10 squared, 10 times 10 is 100. So 10 times 100 equals 1,000. I can take out some of these spaces so they all fit in within the little space. All right, so we have 1,000. And then let's go ahead and do 12. So we have 12. We're going to have 10 times 12 squared. This 10 in front, this 10 is called I'm pausing. It's called the coefficient. That's right. The coefficient is the 10. It's going to stay constant through this whole equation. So then we're going to have 10 times 12 times 12 is 144. So 10 times 144, I'm going to squeeze this in so that it's a little easier to see. And that equals 144, 1,440, 1,440. All right, let's do the next one. So, or actually, let's put these in. So that means for our values, that's going to be 640. That's going to be 1,000. It's not lined up. That bothers me, but hopefully you'll be able to survive. And 1,440. All right, let's do the same thing, but let's go ahead and do it with this equation. You might want to grab a calculator for this one. I have my calculator sitting right there from earlier today. So we're going to go ahead and make the same chart. I like this chart because it helps organize my thoughts. If you have a chart that works better for you, that's fine with me. I like it when my chart is actually even, but we can only have so many dreams in life. All right, so let's go ahead and put in what we've got. So our input side is going to be x. Our equation side is going to be 2 to the power of x, the variable there, and then this is going to be y. So for our first x, we have 8x as our input. That means it's going to be 2 to the power of 8. I don't know what our exponent's going to be. That's 2 times 2 times 2 times 2. Let's clear all. Let's go ahead and do this. So 2, this is the button that you use, to the power of. See how it made it a little exponent? You can also type in there. 8. So 256. So our answer here is going to be 256. Let's do 10. We have 10, pause, 2 raised to the power of whatever our x value is, and our x value is 10. I forgot to put the equals there, but you'll forgive me. All right, so let's try it. So we have 2, and if you're typing on your keyboard, you can use the caret button, and it will automatically do that for you. To the power of 10. Ooh, it's catching up. 1,024. So that y value equals 1,024. We're getting close. I may have actually just overtaken it. All right, so 12. Let's see. 2 to the power of 12. Well, that's just like taking this and multiplying it by 2. So that's 1,000 times 2 is going to be something like 2,000. 2,000 times 2 is going to be something like 4,000. So we're expecting something in the high 4,000s. All right, so let's try it. 2 to the power of 12, 4,096. Right, so our answer here is 4,096. All right, it overtook it completely. So when the value was 8, we got 256, but it pretty quickly took it over. At 10, we got 1,024, and then at 12, it just decimated it. 4,096. Once it gets going, it definitely overcomes it. All right, so the question is, make an observation about how the values of the two expressions change as x becomes greater and greater. I'm going to leave this for you to do, and I'm going to leave this open. So my observation is that as x becomes greater and greater, ... There's your sentence starter. You finish it off, and you can add this. If you want to use the whiteboard, you can use a whiteboard like this. You can take a screenshot of your whiteboard and add it in here. I used a specific color, so I'll know this is my whiteboard, but you can do your own. All right, so we have about 12 minutes left. Let's try 1 and 2. So function is defined, f of x, you remember f of x is just a fancy way of saying y, right? F of x is defined as 1.5 to the power of x. G of x is this quadratic. How did I know it was a quadratic? Well, I know it's a quadratic because it has an x squared. So we know this is going to be a quadratic. Which function, I should have read ahead. Which function is the quadratic? We know that g of x is the quadratic because, here, I'll type it out here. G of x has an x squared, so it is quadratic. You make a definition for when you tell me which one is exponential. The value of which function will be greater for larger and larger values of x. So this is asking, what do we already know? I'm going to make a little arrow and draw it out here. What do we already know? Which function, which type of function will have the larger values when x is very large? In advanced math, like calculus and stuff like that, we have a phrase for this, right? And we say as it approaches, so when it's very large, as it approaches infinity. Now, we don't have to go up to infinity to know that. In fact, back with our last problem up here, we only had to make it to 12 to know that x is going to keep increasing, right? If we do 13, 13 is going to be 8,000 and something, right? So we know that as x gets very large, and we have it in our notebook several times, I'm circling it right now, what the exponential function that as it gets very large. Nice pair of shoes, all the pieces of all the pieces of sand in the whole earth. There's a difference there. All right, create a table of values that show the expression for 3 times 2 to the x shows that this overtakes this. All right, we can do that, right? So this is problem 3. We can make a table of values. Let's do a table of values, but let's go ahead and make our table of values sort of jump up ahead a little bit. So what I'm going to suggest you do, I have about 10 more minutes. So what I'm going to suggest you do is that when we put in our x values, we go ahead and choose things that's going to show that it will overtake it. So if we start with x, let's say if we start with 2, and then maybe we jump up to 5, and then maybe we jump up to 10, and then maybe we're going to go ahead and jump up to 15. It doesn't fit in there. I'm sorry. It bothers me too. Right? So if we jump up to that sort of set, we'll be able to show that maybe it won't overtake it at the start, but it'll overtake it at the beginning. Wow, this is going to be a lot of work, right? So if we put in our first equation, as y equals 3 times 2 to the x, I put my parentheses around on this side, and they put their parentheses on the outside. It's still saying that the exponent is only applied to the things that it's attached to. I just put it like this because it's a little easier to read when you can't do the superscripts, okay? And then on this one, we're going to have it go y equals 3x squared plus 2x. I wonder if there was a way to predict when it was going to overtake it. Actually, you know what you could do? I bet you could graph this. So I'm just going to go grab a graphing calculator and see when it overtakes it. So this is my graphing calculator on Desmos. I have y equals 3 times, you could put a times in there, times 2 to the power of x. That was all on my keyboard. I didn't use any of their buttons, but I could, right? This is what my exponential graph looks like. Notice how it only has one side, but it goes up pretty significantly. And then on this one, we're going to have, it was a complicated one, I think, wasn't it? 3x squared plus 2x. 3x squared plus 2x. Oh, look. Here's where they cross. So they're going to cross at 1.2. Wow. So they're going to cross at 1.2. So maybe if we want to show that it overtakes it, we should also, now that I know that fact, now that I graphed it and looked at it, we should go ahead and show maybe that at 1, it doesn't overtake it. I'm going to do one with you, and then you can go on to do these yourself, all right? And you can build your own table. So 3 times 2 to the first power is 2. 2 to 1 power, that's equals to 3 times 2. And 3 times 2 equals, I'm going to do it underneath, which equals 6. And then if we do the same thing over here, we're going to have 3 times doing 1. 1 times 1 is 1, so 1 squared, which is 1, plus 2 times 1. So that's 3 times 1 plus 2 times 1, which equals a total of 5. So right now, this is already getting bigger, right? All right, let's do one more. Let's just do 10. I'll let you fill in your own numbers, but let's do 10 and show that the exponential is going to be bigger in the end. Let's do 10. So we have 3 times 2 to the power of 10. 2 to the power of 10 was 1,024. I don't know what 1,024 is times 3, but let's go look it up. So 3 times, oh, sorry, I need to clear. 3 times 2 to the power of 10, 3,072. So I'm just going to add that in, equals 3,072. And then let's see what this one is. So 3 times 10 squared plus 2 times 10. So that's 10 times 10 is 100, so that's 300 plus 20, so 320. What we can see is that this is quite a bit smaller than this one. All right, in the last 5 minutes, let's look at this one. The table shows the values for our exponential and our quadratic. Use the pattern in the table to explain why the values of the exponential will overtake the values of the quadratic, even though it's times 100, right? Could you fill out the rest of these? Could you fill in values to show that the exponential will eventually overtake the quadratic? Of course you could. Let's prove it by doing one example, and then I'll let you prove it in your own table. So I'm going to pick a big number. So 5, they're getting pretty close. So let's go ahead and let's do 15. Why not? So we have 15 equals x. So we're going to do 15 as x, right? So our first value, I'm sort of trying to go underneath I'm trying to kind of go underneath here. So we have 4 to the value of 15. I have no idea what that's going to be. And then over here, we're going to have 100 times 15 squared. Right? Let's find out what those are. Close that. So 4 to the power of 15. Haha! That's a 1 with 9 zeros behind it. I'm going to estimate that. So we're going to have 1.07 approximately. So we have approximately 1.07, so 9 zeros. 1, 2, 3, 4, 5, 6, 7. So 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros behind it. And then let's do this one. So we're going to have 15 squared times 100. Oops, I forgot to write that in. So 15 squared times 100. 22,500. So our value here is 22,500. Well, I don't know about you, but I'm a big fan of the thing with 9 zeros behind it. So I think that pretty much proves that it is definitely bigger. All right, so if you have any trouble, you can send me an email. Answer these questions in your own Google Doc, and it is due Friday for homework. Capitalized Friday. I'm ignoring it. Okay, wish me luck.